Hi my dear students, welcome back to our amazing channel of Brilliant QATAR. In today's session of JEE Mathematics, we'll be discussing basic mathematics. In this basic mathematics, we'll be discussing logarithms, basic inequalities and modulus functions. First, we'll start with basic inequalities, okay? Before we start basic inequalities, let's understand the importance of the intervals. There are four types of interval, four different types of intervals we have. Okay. Number one, open interval. Number two, closed interval. Number three and four are semi-closed or semi-open intervals. First, let me clearly explain this particular type. Let's consider, let x be any real number. X be any real number. Even a comma b are also real numbers such that a is less than b. A comma b are any two real numbers such that they are less than b. A is less than b. Now, my dear friends, see. If x is a real number, x belongs to capital R and a comma b are also two real numbers, two fixed real numbers. But I am not fixing anything. X be any variable. X can be any real number. But a comma b are two fixed real numbers. Like 2 is a number, 3 is a number, 5 is a number, 2.5 is a number. It's a fixed number. Let's try to fix it. Okay. And x is not any, let x be not any particular fixed variable. Let x be a variable real number. Number one, if I consider x belongs to open A to open B, if I say x belongs to open A comma B, then I mean to say that this particular set x takes all the real numbers which lie in between A and B, but not A and not B. Okay? If x belongs to open interval A comma B, then I mean to say that x such that x lie in between A and B. X takes all the real numbers which lie in between A to B. Suppose if I take x belongs to some 2 to 5, open 2 to 5, then x takes all the real numbers which greater than 2 and less than 5, but not 2 and not 5. X won't take 2, x won't take 5. These extremes won't be included for x. But x takes all the real numbers which lie in between 2 and 5. How many real numbers do lie in between 2 and 5? Infinite real numbers will be lying in between 2 and 5. So first case, if x belongs to open A to B, then x takes all the real numbers which lie in between A to B, which lie in between A and B, except the extremes. That means A is not included. In the same way, B is also not included. Now, if I do consider x belongs to closed A comma B, closed brackets or square brackets we say, closed interval. If I say x belongs to closed A comma B, then x such that A is less than or equals to x is less than or equals to B. In this case, I mean to say x takes all the values, all the real numbers which lie in between A and B. Yeah. But apart from this, x also takes even the extremes, endpoints also. That means both A and A is included and even B is included. In the first case, that's the reason I just kept only inequality, only less than A less than x less than B. But in this second case, apart from inequality, I also include equality. I have also included equality. Okay? So, if I say x belongs to closed A comma B, whenever we have closed brackets, make sure that along with inequality, equality also has to be mentioned. That means even endpoints also should be included. Now, third and fourth both are similar. If I say open closed or closed open, if I say open closed, first bracket will be open, second will be closed. If I say closed open, first bracket will be closed, second will be open. Now if I say x belongs to closed A to open B, then I mean to say that x takes all the real numbers lie in between A and B, but x is only this particular endpoint, only A is said to be included because A is bounded by closed bracket but not B. Clear? A is bounded by closed brackets and not B. So, if X belongs to closed A to open B, then I mean to say A is less than or equals to X less than B. In the same way, if I take X belongs to open A to closed B, I mean to say X takes all the real numbers in between A to B. Apart from that, X also includes the real number B. This is what the beauty of 4 different types of intervals that we have. Number 1, open. Number 2, closed. Number 3, open, closed. Number 4, closed, open. Only 4 different. Apart from this, we also have curly brackets. Suppose if I say X belongs to curly brackets A comma B. Curly brackets A comma B. Then in this case, it is so simple that X takes only A and X takes only B. Only A comma B. That's it. No other go. If I say curly brackets, if I say X belongs to or X equals to X belongs to 2 comma 5, then X can take only 2 and only 5, not the real numbers which lie in between them, which do not lie in between them, nothing. Only 2 and 5, that's it. Already we have seen this in our sets also, okay? So, briefing, open interval, closed interval, open, closed, closed, open. We have seen this. Next, how do we solve inequalities? How do we solve inequalities? See, till now we have seen many things with respect to equalities. Suppose, what do you mean, how did we solve equalities? X minus 2 is equals to 5. So simple, X is equals to, if we take minus 2 to the right hand side, it becomes plus 2. 5 plus 2, X is equals to 7. That's how we solved equalities. But coming to inequalities, most important thing, first let's understand the basics in solving basic inequalities. See, rhyming, understand the rhyming. Let's understand some basics in solving basic inequalities. Okay? Okay? Now, chalo guys, first, we'll be allotted with a particular polynomial function, okay, algebraic function, something like some f of x greater than or equals to some a or something, f of x by g of x or f of x by k of x. In that way, a particular polynomial function they give. First, we have to make sure that right hand side should be 0. Right hand side it should be 0. So how do you get right hand side 0? Do we transpose to it in division? You can't. Whatever the things that we did in terms of equality, the same things are not going to be done in this. I'll tell you why in the future coming sessions. But now make sure you are going to take it as a difference. Now we say f of x minus a will be greater than or equals to 0 or greater than 0 or less than 0. Then you are supposed to factorize this, factorize everything. So whatever the expression that they give in the beginning, suppose if I say, see, x square plus 3x greater than minus 2. X square plus 3x greater than minus 2. First get it to the left hand side. So x square plus 3x plus 2 should be greater than 0. Now whatever we have, this has to be factorized. This has to be written in this particular form. Now I can factorize this as x plus 1 times x plus 2 greater than 0. First, the primary thing is whatever the inequality expression that they have given, that has to be factorized, and right hand side should be only 0, only 0. Okay, so that I mean to say, firstly we have to convert the given algebraic or polynomial or any particular function which is given has to be converted in this form. We have to take it as g of x is equals to, now once we take that, see, they have given something like g of x greater than or equals to 0. Now whatever this, consider this as g of x. Suppose g of x is in this form, some x minus b1 raised to k1, x minus b2 raised to k2, and so on, x minus bn raised to kn, in the same way denominator. Now where k1 comma k2 and r1 r2 belongs to capital N and can be real numbers. Now the most important, first I'll go with this particular thing. Same expression that we have taken, x square plus 3x greater than minus 2. So x square plus 3x plus 2 will be greater than 0. Okay, now this can be factorized as x plus 1 into x plus 2 greater than 0. So according to them, they are asking us to take this as g of x. Once you factorize the left hand side expression, whatever we have, take it as g of x. Complete that thing. So definitely g of x is going to be in this form: x minus b1 raised to k1, x minus b2 some. Suppose you can even like x minus 2 raised to 5 into x plus 3 raised to 10 whole divided by x plus 5 raised to 2 into x plus 1 raised to 3 greater than or equals to 0. Now we have to take this as g of x. First thing, we have to take this as g of x. Next, point number 2. Now once we take that particular function as g of x, as we have g of x greater than or equals to 0. Now we have g of x is equals to, what do we have in the previous expression? X minus 2 x plus 3 whole divided by x plus 5 x plus 1 x minus 3 raised to 5 10 3 2 5 10 3 2. Now we have this. Okay, point number 1, steps. Points where numerator becomes 0 are called zeros. See, all the now at which particular points where here numerator is getting 0. See, here we have two factors in numerator, x minus 2 raised to 5, x plus 3 raised to 5. When x is equals to 2, numerator becomes 0. When x is equals to minus 3, numerator becomes 0. So here 2 comma minus 3 are the 2 points where we are getting numerator 0. If x is 2 or if x is minus 3, we are getting numerator 0. Such points are called as zeros of the given g of x. Zeros we say. Okay. The points where numerator becomes 0 are called zeros, and points where denominator getting zeros. See, if you take x is equals to minus 1 or x is equals to minus 5, we say poles of the given function, poles of the given expression. Numerator may roots or zeros, denominator may poles. Okay, now first we find the zeros and poles of the function. What are the things that we have? We have 2 minus 3 minus 1 minus 5. Coming 2 comma minus 3 are zeros, whereas minus 1 comma minus 5 are poles. Next, then we mark all the zeros and poles on the real number line. Okay, let's see. In ascending order, first minus 5, minus 3, minus 1, plus 2. Clear? Minus 5, minus 1, minus 5, minus 3, minus 1, plus 2. Now, then we mark all the zeros and poles on the real number and put a vertical line thereby dividing in many intervals. Now, see, our complete from minus infinity to infinity, we have real numbers from minus infinity to plus infinity. Now, this minus infinity to plus infinity has been divided into how many intervals? You see, 1, 2, 3, 4, 5. 5 intervals by these 4 critical points. By these 4 zeros or poles. Clear? Now what we are supposed to do? This particular method, whatever the method that I am going to explain it now, is called as wavy curve method, and please pay attention in understanding this. Once you understand wavy curve, remember this in this way, wavy curve, once you understand this wavy curve, my dear friends, just trust me, you are going to solve inequalities within seconds, within even fractions of seconds. In that way, that is the beauty of wavy curve method. Okay. Let's do understand how do we solve the inequalities by using wavy curve method. Chalo. First thing, from the top curve from infinity, you just join to the first critical point that you have from right side. Okay, from infinity to 2, we have joined from that 2 from top. Once we have it here, now check where we have this critical point 2, x minus 2. X minus 2 raised to even power or odd power. We have to check x minus 2 raised to even power or odd power. Luckily here we have odd power. If x minus 2 raised to odd power, we have to change the path of the curve. What do you mean by path? Now we are in the top. By default, first thing is from here we will be drawing to 2. That means we are above the number line. Now, if the power is odd, we have to change the path of the curve. That means we'll be going to the below number line. Now, to next critical point that we go. Next, we stop at x plus 1. Here, because we are at a minus 1. X plus 1 is the factor. X plus 1 is raised to even power or odd power? Odd power. Again, we are supposed to change the path of this particular thing. Now, at minus 3, x plus 3 raised to, now you see, x plus 3 raised to even power. When a particular factor raised to even power, when a particular factor raised to even power, in that case, what we are supposed to do? We are not supposed to change the path of that particular curve. That's it. Keep this in mind. When a particular curve, when a particular factor raised to odd power, even power, we are not going to change the path of the curve. That mean to say that, I mean to say that we are not going down now. We will be staying in the same way here. Clear? TK. Now, we are at minus 5. Minus 5 means x plus 5 is the factor. Now, you can say clearly, x plus 5 raised to even power again. That means still we will be in the same path. That means we'll be in the top only. That's it. This is how we draw the wavy curve. I hope you understood, my dear friends. I'll be explaining it again. Please have some patience and do understand this, because once you understand how do we solve inequalities by using wavy curve, you will be solving inequalities in just fractions of seconds, not even seconds, in just fractions. Clear? Now, firstly, from above the number line, you have to start tracing the curve above the number line to the first critical point from right that you have. Okay, so from infinity to 2 you got. Next, at 2 you stop. Look at the factor. This factor raised to odd power. Change the direction till next critical point, minus 1. X plus 1 raised to odd power again. Change the path. We are in, till now we are in below the number line. Now we are supposed to go to the above number line. Next, at minus 3, x plus 3 raised to even power. So we'll be in the top only, above the number line only. Next, minus 5, x plus 5 raised to even power. Still we will be continuing in the top of above number line only. Now, once we get this, look at this. Now we need greater than or equals to 0. Greater than or equals to 0. Greater than or equals to 0. So, greater than means the region which lies above the number line. The region which lies above the number line. Now, wherever we have curve above number line, it's our region. Now, wherever we have curve from minus infinity to minus 5, we have union. Minus 5 to minus 3, we have union. Minus 3 to minus 1 we have union 2 to infinity. You might be getting doubt, sir, why did we take closed brackets? Whenever we have equals to sign along with inequality, take closed brackets. Now, is this really making sense? Sir, you're from minus infinity to minus 5 you have gone, included minus 5. Again from minus 5. Is this necessary, sir? Not at all necessary. I can clearly write this as combined thing. So from minus infinity to minus 1 I can write directly. Because see, there is no disjoint sets also. Minus 5 to union 5. Everything is being included. So why do you write it into that many number of intervals? Not necessary. From minus infinity to minus 1, union closed to infinity. But is that done? No. You know why? Because, my dear friends, the denominator poles shouldn't be included in the denominator poles. That means the denominator, these minus 1 and minus 5 should never be included in the solution. Now, can you see minus 5 and minus 1 are, yes, they are in this. Why? Because if x takes minus 5, what happens? Denominator becomes 0, completely it is going to be not defined. So how can you accept a not defined value in the domain? No, na. That means you are supposed to eliminate these two values. For that, what I do, I'll just, instead of removing minus 1, I just put open brackets here. X belongs to minus infinity to minus 1, open brackets now. Union closed to infinity. Am I done clearly? No, because minus 5 is included. So for that I just minus 5. That means I am eliminating minus 5 from the whole solution. So for this particular thing, finally, what can be the solution that I can give? X belongs to minus infinity to minus 1 union closed to infinity. From this subtract minus 5. Subtract means eliminate minus 5 from the solution that you got. That's it. So I read out the instructions. Points where numerator becomes 0 are called zeros or roots. Points where denominator becomes 0 are called poles of the function. First we find zeros and poles of the given function. Then we mark all the zeros and poles on the number line. Determine sign of the function in any of the interval. Then by using this, how do we determine? That means, see, if the curve is above number line, then it is positive. Below number line, negative. So a positive means greater than 0. Negative means less than 0. So for greater than 0, that's the reason we take the solution which lies above the number line. For less than 0, we take the solution which lies below number line. Clear, guys? Clear? Clear. I know it's clear. Good. We'll solve this, a particular beautiful example that we have it. X minus 2 times x minus 4 times x minus 6 greater than 0. It's already been factorized. So now you see what happens. Just find out all the roots that are zeros. X can take 2, 4, 6. Because if x is 2, whole becomes 0. If x is 4, whole becomes 0. X is 6, whole becomes 0. Now draw a number line. Minus infinity, plus infinity. Arrange these 3 critical points on the number line in ascending order. Luckily, they have already been assigned in ascending order. Now draw wavy curve. Wavy curve. How to start wavy curve? From infinity to 6 to the first critical point we generally come. Now we look at x minus 6. X minus 6, the factor x minus 6 is having only clearly, the factor x minus 6 is having clearly an odd power. The power is 1 here. That means an odd power. So we can change the path of this particular curve. Till 4 again. X minus 4 is again having odd power. X minus 2 is again having odd power. That's it. See? Wavy curve. That is the reason why we said wavy. Okay. Now, look at the wavy curve for the given inequality. Now, according to that, the region which lies above number line is positive, below number line is negative. We need greater than 0. That means only open brackets. That too above. So, x belongs to, what to say? From 2 to 4, union 6 to infinity. See, the beauty. So simple, so simple. Imagine that if the same problem been asked for less than 0. If the same x minus 2 times x minus 4 times x minus 6, if it is less than 0, what could be the solution? If it is less than 0, what could be the solution? The same, the region which lies below number line is our solution. So starts from minus infinity to 2, union from 4 to 6 we have below. See, understand the beauty of this. None of the points, these two are same. Because if a particular x value, the function is getting negative, how can this, for the same value the function gets positive? That's the reason. We can even see that here. Clear? Let's go with the next question. Let's go with the next question. X into x plus 1 whole divided by x plus 2. X into x plus 1 whole divided by x plus 2. Now let's see, my dear friends. This x can be written as x minus 0. That means 0 is one of the critical point that we have. 0 root into x plus 1 whole divided by x plus 2. Greater than 0. Greater than 0. Now what are the critical points that we have? Numerator 0, minus 1, denominator minus 2. 0 comma minus 1 are zeros. Denominator, that minus 2 will be poles. First, before going with that. Now, what are we supposed to do? Draw a number line. Plot all these critical points. Plot all these critical points on the number line. In ascending order, that too. Minus 2, minus 1, 0. Now start drawing wavy curve. First from infinity to the first 0, that too from above number line. Okay, that is by default. That is by default. Next at 0 we stop. X minus 0 raised to 1. 1 is odd number. So we can change the path of the curve. Next at minus 1. X plus 1, even x plus 1 also raised to odd power. Even x minus 2 also raised to odd power. That's it. That's it. Now we need greater than 0. That means the region which lies above the number line. Minus 2 to minus 1 union 0 to infinity. Minus 2 to minus 1 union 0 to infinity. But from the basic things, what did we discuss? Make sure that in the solution, if the denominator poles are included, that means if this minus 2 is included, remove it. Now, can you see whether minus 2 is included or excluded in this? Excluded, because we have open brackets for minus 2. Clear? Very good, very good, very good, very good. Next question. X minus 2 whole square into x plus 1 whole cube into x minus 4 less than 0. I'll give you 1, 2, 3, 4, 5 seconds to do this. Yeah. First thing, let's find it together. All the poles or zeros or roots. We have only zeros because there is nothing in the denominator. So luckily, x can take 2, minus 1 and plus 4. X can take 2, minus 1 and plus 4. 2, minus 1, plus 4. Clear? Now, these 2, minus 1, 4 are the zeros of the given function that we have. Draw a number line from minus infinity to plus infinity. Now, plot all these number line, plot all these points on the number line in ascending order. Minus 1, plus 2, plus 4. Now, draw wavy curve. Wavy curve has to be started at infinity to 4. At infinity to 4 at first. Then at 4, look at the power of x minus 4 is being raised. Here x minus 4 is raised to odd power. Hence, as the power is being odd, we can change the direction of the path of that particular curve. So from 4 to 2, it can be drawn from below the number line. Now at x minus 2, here x minus 2 is raised to even power. Since x minus 2 is raised to even power, the path of the curve shouldn't be changed. I mean, we are in below the number line. The same below number line has to be continued till we move to the next critical point. Then at minus 1, x plus 1 whole cube is raised to odd power. X plus 1 raised to odd power. Then as the power is being odd, we can change the direction of this particular curve. That's it. Now, this is what the wavy curve. By using this particular wavy curve, we need less than 0. That implies all the region which lies below the number line has to be included in this. Therefore, x belongs to minus 1 to minus 2 union 2 to 4. Majority of the students will be asking, sir, can't you include this 2 directly? Yes, we can include. When can we include? If it is just less than or equals to. If equality also holds here, then we can add closed brackets. But here as we have only less than 0, we are not supposed to include that minus 2. That's the reason x belongs to open minus 1 to minus 2 union 2 comma 4 we have. That's it. Clear? Here see the most important thing, this particular function g of x is being splitted into 3 factors, x minus 2, x plus 1, x minus 4. The first factor raised to even power and the remaining 2 odd power. So that's the reason we have not changed the path of the particular wavy curve when we came at across x is equals to 2. Clear? One more last question. X by x plus 2 less than or equals to 1 by x. First we have to the most important primary thing that we have is the left hand side should be only 0. Left hand side should be only 0. So x divided by x plus 2 less than or equals to 1 by x. That 1 by x I am bringing it to the left hand side. So minus 1 by x less than or equals to 0. Now I can factorize this. I can cross multiply x into x square minus x minus 2 whole divided by x of x plus 2 less than or equals to 0. This particular numerator can be factorized. This numerator can be factorized. How it can be factorized? It can be written as x square minus 2x plus x minus 2 whole divided by x of x plus 2 less than or equals to 0. Now we get x minus 2, x of x minus 2 plus 1 of x minus 2 divided by numerator we have x of x plus 2. Has to be completely less than or equals to 0. Now numerator is completely factorized, x plus 1 times x minus 2 whole divided by x of x plus 2 less than or equals to 0. Now it's completely been factorized. We can find zeros and poles of this particular function. Let's do understand. What are the things? Minus 2 plus 2, minus 2 plus 2, 0 and minus 2. These are the 4 zeros or poles we have it for g of x. Now let's arrange these poles or zeros on the number line in ascending order. We start with minus 2, then minus 1, then 0, then 2. Then we'll go with wavy curve. Starting from infinity to 2 to the first critical point that we have. Then at x minus 2 we have odd power. Luckily all are odd powers. Then we can just go with the simple wavy curve that we have. See, that's the reason it is called as wavy curve, as all the factors involved in this particular expansion are already been only odd powers. So that's the reason I have drawn a simple wavy curve passing through all these critical points. Now I need only less than or equals to 0. Less than or equals to 0. That means the region which lies below the number line. Below the number line it takes x belongs to, I am taking closed brackets. Why do we take closed? Because we have, apart from inequality, we are having equals to also. So x belongs to minus 2 to minus 1 union 0 to 2 closed. But this is not going to be the final answer. You know why? As I already said, we have 2 poles here, 0 and minus 2. These 2 poles, if these 2 poles are going to be involved in the solution, then we are going to eliminate them completely from the final solution. That means from the final solution, make sure that you are going to eliminate this 0 and minus 2. So wherever we have them associated with the closed brackets, just to keep open brackets. So x belongs to open minus 2 to closed minus 1 union open 0 to closed 2. That's it. This is going to be the final solution of this given inequality. Why did you eliminate minus 2 comma 0? Because they are the poles of the given g of x, poles of the function. If x takes minus 2, denominator becomes 0. If denominator becomes 0, whole expression is going to get not defined. We can't include any not defined or indeterminate values for the given expansion. That's it. Okay, with that we have completely completed basic inequalities. I hope each one of you who have watched this particular session have understood how to solve basic inequalities by using a beautiful method called wavy curve method. Okay, till we'll meet in the next session. Till then, take care everyone. Bye. See you in the next session.